This is the fourth slide presentation of the gazebo and boardwalk I built. The first one covered site preparation and framing of the gazebo. The second one was about decking the gazebo. The third covered framing and decking the boardwalk and designing the stairs. This one will show how I built the roof and rail posts, as well as how I built and installed the overhead spindles. With the deck of the gazebo complete, it was time to make and install the roof and railing support posts. I used that lap joint I mentioned earlier. This was a test cut. I used a digital blade height measuring tool. It worked great for setting the blade height on the table saw. So, now the blade height was just a hair higher than half the thickness of the 4x4. The distance from the fence was exactly 1 11/16 inches. That put the cut dead center. I marked on the 4x4 how far I wanted the cut to go, and using some masking tape, I set a line on the table saw indicating where the blade starts. I started cutting, and when the two lines lined up, I knew that was where I wanted to stop. And the lap joint cut lengthwise, marking the cross cut with the circular saw, and finishing the cut with the Sawzall. I routed the edges of the railings with the roundover bit to give them a more finished appearance. Railing support posts ready to be installed. But first, I doused all the cuts with wood preservative. I installed a 4x4 rail post midway between each roof support post. I used two galvanized 3/8 inch diameter by 4 inch long carriage bolts. Noticed I cut the end at a 45-degree angle to give it a more finished appearance. Getting ready to install the roof support posts. I used a cardboard template to line up the holes on the post with the holes on the ends of the two 2x12 joists that are holding the posts. The two extra holes in the template were a mistake. I didn't use them. Roof support posts were installed using 4 galvanized 7-inch long by 3/8 inch diameter lag screws. Gazebo roof and rail posts installation completed. Here's a completed spindle assembly. A total of 8 were needed. I bought the 128 spindles I needed at SNL Spindles, slspindles.com. Top quality. They have a selection of pressure-treated and cedar spindles, balusters, handrails, and much more, and the quality is exceptional, far above what you would find in your big box stores. I paid a little more, but it was well worth it. I added a third work table to the center of the gazebo while making the spindle assemblies. As usual, I started by making a drawing. Here's a full-scale drawing of the spindle assembly. Bottom rail outlined in red, made from a 2x4. Top rail. The top rail, a 2x4, has a 3/4 by 3/4 inch dado that I'm planning on running wiring through to 8 spotlights mounted on each of the roof supports. The spotlights will be pointed upwards towards the inside of the roof. 1/2 inch by 1.5 inch lattice strips were used to hold the spindles. I used two 2-inch brads using a pneumatic nailer to attach each end of the spindle. I angled the brads inward slightly so that they wouldn't pop out of the sides of the spindles. And the 9-inch spindle. Once the spindle lattice strip assembly was complete, I nailed it to the top and bottom rails. once again using a pneumatic nailer and 2-inch brads. Using a stacked dado blade to cut the channel for the wiring, and the finished dados. I made some test cuts to decide which router bits I wanted for the top and bottom rails. And these are the ones that I decided on. The bottom spindle assembly railings milled. Now it was time to measure and cut the railings for the spindle assembly to their proper length and angle. I started by using a digital sliding bevel. Laying it flat, I zeroed out the bevel. That gave me a 180-degree reading. Okay, here's how I use the bevel. I hope I explained this well. Here's a top-down view of one section. To the left and right are the roof posts. In between them is a railing post. Here's a close-up of one roof post and the railing post. In between, I lined up a 1x4 measuring stick that I rested on stop blocks that were clamped to the posts. Notice the gap between the measuring stick and roof post? That's not important, as I just needed for the measuring stick to be close enough for the base of the bevel, colored purple, to rest on the edge of it. Then I rotated the blade of the bevel, colored in yellow, until it rested on the side of the roof post. That gave me a reading of 112 degrees. Plugged the angle into the calculator, subtracted 90 degrees from the angle, and that gave me the angle I needed of 22 degrees to set on my miter saw, and then I made the cut. I used the same angle to measure and cut the bottom rail and lattice strips. There's a 2x6 and 2x4 on top of the spindle assembly that will be attached to the roof posts and supporting the roof rafters. They also had to be cut at that angle. The 2x6 had to be mitered, so I used the same angle to set my saw. Then I made the cut. Now it was time to cut the bottom and top rails to the proper length. I carefully measured from inside edge to inside edge of the adjoining roof supports. I set a nail on the inside edge of the top rail and used the nail to hold the tape measure while I measured for its length. I used the same procedure to measure and cut the angles for the opposite ends as I did with the first. The company that I bought the spindles from, S&L Spindles, slspindles.com, had a link on their website that went to a website called blocklayer.com. That had all sorts of apps for calculating spacing for building materials, such as brick, concrete, etc. One app calculated spacing for balusters. I used that app to determine spacing for my spindles. I cut a piece of scrap to the distance for spacing I got from the app and laid out where the spindles needed to go on the lattice strips. Then I started nailing the spindles to the lattice strips. I used an 8-foot 2x4 as a stop to keep the impact from the pneumatic hammer from moving the spindle assembly. The spindles are 1 3/8 by 1 3/8 inches. The lattice strips are 1.5 inches wide, so I cut 1/16 inch spacers to keep the spindles centered on the lattice strips. You can just see the one spindle resting on them. And the top and bottom railings attached to the lattices. The assembly in the slide is actually upside down. Notice the dado on the top railing, resting on the work table. All 8 spindle assemblies completed and ready to be installed. I used 3 ladders to install the spindle assembly and roof rafter supports, a 6, 8, and 12 footer. Holes in the roof post for the wiring lined up with the dados in the spindle assemblies. The spindle assembly clamped in place and ready to be screwed down. And the 2x6 and 2x4 rafter supports added. And lots of clamping. I even used a pipe clamp in the reverse position to push the roof posts apart for a section that was too tight. And here's what it looks like finished. Amazingly, all the 4x4 roof supports are plumb.